In this presentation, we are talk about NP scattering at low energies. To describe the low energy scattering, we have to go for the technique partial wave analysis. Using the technique partial wave analysis, we can evaluate the value of scattering amplitude f of theta. Once the value of theta is known to you, we can estimate the differential scattering cross section using the formula sigma of theta equal to absolute square of f of theta. Once the differential scattering cross section sigma of theta is known to you, we can estimate the total scattering cross section. Sigma total is equal to 2 pi into integral of sigma theta sin theta d theta. If the energy of the incoming neutron is lesser than 10 million electron volt, only a wave with orbital angular momentum quantum number L equal to 0 is sufficient to describe the scattering process. Such wave is called as S wave, because in the case of NP scattering, the incoming neutron beam is taken as a plane wave. The plane wave is a superposition of infinite number of spherical waves. The individual waves are called partial waves. A wave with orbital angular momentum quantum number L equal to 0 is called S wave. A wave with orbital angular momentum quantum number L equal to 1 is called P wave, and a wave with orbital angular momentum quantum number L equal to 2 is called D wave. In the case of NP scattering, if the energy of the incoming neutron is lesser than 10 MeV, only the S wave is sufficient to describe the entire scattering process, which means that the orbital angular momentum quantum number L is equal to 0. Therefore, the angular distribution of the scattered neutron is isotropic. To describe the scattering process, we have to consider the Schrodinger equation for a central potential. Here mu is reduced mass, that is mass of the proton into mass of the neutron divided by mass of the proton plus mass of the neutron. Here the mass of the proton is almost equal to the mass of the neutron. Consider the mass of the proton as capital M, then m square divided by 2m is equal to m by 2. This is our reduced mass. Now the solution to equation 1 is given as psi of r comma theta equal to RL of r into PL of cos theta. Actually, the Laplacian operator is expressed in terms of spherical polar coordinates r theta and pi, whereas the solution to the equation 1 is expressed only in terms of r and theta. Here RL of r is a radial part. The radial wave equation is given by equation 3. We arrived at this radial part from the method of separation of variables. We arrived at the same in the previous case also, that is in the case of ground state of neutron, we derived this relation. Here I have just considered that relation. If the distance of separation between the proton and neutron is greater than the range of the nuclear force, the effect of potential is 0. Therefore, in the equation 3, the value of 2 mu v by h cross square is equal to 0. Now the equation 3 is modified in this form. Without this factor, we have written equation 3. If you substitute the value of 2 mu e by h cross square by k square, we can get equation 4. Now we have to write the solution for equation 4 using spherical Bessel function JL of kr and spherical Newman function eta L of kr. This is the value of JL of kr, 1 by kr sin kr minus L pi by 2, whereas eta L of kr is minus 1 by kr cos kr minus L pi by 2. Now the general solution of equation 4 is RL of kr is equal to A dash JL of kr minus B dash eta L of kr. Now substitute these two values, we can get this equation 5. Now consider if the neutron beam is in the vicinity of the proton, which means that the distance of separation between the proton and neutron is lesser than the range of the nuclear force. It is R less than R0. The effect of potential is taken on account. V of R not equal to 0, it is having some value. To find out the value of RL of KR at this case, replace A dash by means of AL cos delta L and B dash by means of AL sin delta L. See here, already sin term is present here, therefore A dash is expressed in terms of AL cos delta L. Here cos term is available, therefore B dash equal to AL sin delta L. Here delta L is the phase shift. If you substitute the values of A dash and B dash, you can get the equation. Now take out AL by KR outside. It is modified as sin KR minus L pi by 2 into cos delta L plus cos KR minus L pi by 2 into sin delta L. Using the formula sin A plus B equal to sin A cos B plus cos A sin B, the above relation is modified as RL of KR is equal to AL by KR into sin KR minus L pi by 2 plus delta L. Here delta L is the phase shift. Phase shift measures the amount by which the phase of the radial function for the given orbital angular momentum quantum number L differs from the corresponding one for the V equal to 0 case, which talks about the effect of potential on the incoming particle. That is called the role of phase shift. Now the wave function psi of r comma theta is equal to the value of RL of R into PL cos theta, that is AL by KR sin KR minus L pi by 2 plus delta L into PL cos theta. But the wave function psi of r comma theta is expressed in terms of two factors. One is the incident wave and another one is the scattered wave. In this case, the incident wave is a plane wave. E power ikz is our plane wave. Then the scattered wave is given by the formula f of theta into e power ikr by r. Here f of theta is the scattering amplitude. Whereas the value of e power ikz is I power L 2L plus 1 JL of kr PL cos theta. Now the value of JL of kr is 1 by kr into sin kr minus L pi by 2. So that is I power L 2L plus 1. Instead of JL of kr, we have to write sin kr minus L pi by 2 divided by kr. So this is the kr into PL cos theta. But sin kr minus L pi by 2 is expressed in terms of e power I theta minus e power minus I theta whole divided by 2I form. Say e power I into kr minus L pi by 2 minus e power minus I into kr minus L pi by 2 whole divided by 2I. This is the value of sin kr minus L pi by 2. Sin theta equal to e power I theta minus e power minus I theta by 2I. Using this formula, we have expanded sin kr minus L pi by 2. This is the value of e power ikz. So psi of r comma theta equal to e power ikz plus f of theta e power ikr. So that psi of r comma theta equal to, we have to write all the terms plus this term f of theta e power ikr by r. Now this is equation 8, this is equation 6. The left hand side should be equal to the right hand side. See here, this is the left hand side, psi of r comma theta. This is the left hand side. Right hand side is AL by KR sin KR minus L by 2 plus delta L into PL cos theta. Come to that equation. So L by KR sin KR minus L by 2 plus delta L PL cos theta. Now expand this in terms of e power I theta minus e power minus I theta whole divided by 2I formula. So these terms are present as such, e power I KR minus L by 2. These are all present as such, PL cos theta, f of theta, all are given. Whereas the right hand side is AL by KR. This sine function is e power I into KR minus L by 2 plus delta L minus e power minus I into kr minus L pi by 2 plus delta L, entire is divided by 2i. Take this 2i outside. It is L by 2i kr. Entire should be multiplied by PL cos theta. This is the value of right hand side. See the equation. Left hand side is known to you. This is right hand side. This term is expressed in terms of e power I theta minus e power minus I theta by 2i. So this should be modified in terms of e power I into kr minus L pi by 2 plus delta L minus of e power minus I into kr minus L pi by 2 plus delta L. Entire is multiplied by PL cos theta. The equation 10 is very important. Now we have to equate the coefficients of e power minus IKR and e power plus IKR. On equating the coefficients of e power minus IKR on both sides of equation 10. See here, this term is having no e power minus IKR term, but here this is having e power minus IKR term. Actually, here the terms are, the meaning is e power minus IKR plus IL pi by 2. This is equal to e power minus IKR dot e power IL pi by 2. If you equate the coefficients of e power minus IKR, just this term e power IL pi by 2 is present. All other terms are in multiplication, so just we have to return I power L 2L plus 1 divided by 2i kr. Here the negative sign is present, that is a negative sign, into PL cos theta. The second term, no e power minus IKR term is present, so this is cancelled out. Now come to this right hand side. This is free from e power minus IKR, but this is having e power minus IKR. If you do the multiplication, this minus sign is taken out, minus AL 2IKR. Then if you do the multiplication, you can get e power minus IKR plus IL pi by 2 minus I delta L. This is equal to e power minus IKR into e power IL pi by 2 into e power minus I delta L. Just we have to use the rule a power m into a power n is equal to a power m plus n. See here, we are in the position to equate the coefficient of e power minus IKR. So without this term, you have to write all other terms. See here, minus this negative sign, minus AL by 2IKR. Then without e power minus IKR term, we have to write all other terms. E power IL pi by 2 into e power minus I delta L into this term PL cos theta. Now AL is equal to I power L 2L plus 1 e power I delta L. If you put AL is equal to this term, left hand side is equal to the right hand side. So from the above equation, we can get the value of AL. Minus minus cancelled out. Here 2L plus 1 term is present, I power L term is present. Such terms are not available here. So AL is equal to I power L 2L plus 1. Additionally, e power minus I delta L term is present here. Therefore, AL should be having e power plus I delta L. Instead of AL, if you put these values, the left hand side is equal to right hand side. Therefore, the value of AL is this much. Now, on equating the coefficient of e power IKR on both sides, see here, e power plus IKR. This term into e power minus L pi by 2 into PL cos theta. But here no e power plus IKR term is present here in this case. Here only e power plus IKR is present. So I power L 2L plus 1 divided by 2 IKR e power minus IL pi by 2. That is the first term into PL cos theta. Here e power IKR term is present. Therefore, 1 by r into f of theta or f of theta by r. Now come to the right hand side. E power IKR. AL divided by 2 IKR into e power minus I L pi by 2 into e power I delta L. See here. This should be multiplied by PL cos theta. Here no e power plus I car term is present. Therefore, on equating the coefficients of e power I car on both sides, we can get these terms. In the above relation, we have to substitute the value of AL as I power L 2L plus 1 e power I delta L. Just we have substituted. We may have the equation of this form. Here e power I delta L into e power I delta L is e power 2I delta L, e power minus IL pi by 2 PL cos theta. We have I power L is equal to e power IL pi by 2. This I power L is equal to e power plus IL pi by 2. Therefore, instead of I power L, if you put e power plus IL pi by 2, these two terms are cancelled out. Here also, these two terms are cancelled out. Therefore, we can write 2L plus 1 divided by 2I kr PL cos theta f of theta by r is equal to 2L plus 1 divided by 2I kr e power 2I delta L into PL cos theta. Our aim is to find out the value of f of theta by r. F of theta, first of all, find out the value of theta by r. F of theta by r is this term minus of this term. 2L plus 1 divided by 2I kr. Take out this term as a common one. E power 2I delta L minus 1 into PL cos theta. Actually, this is in this form. Interim stage is 2L plus 1 divided by 2I kr e power 2I delta L PL cos theta minus of 2L plus 1 divided by 2I kr into PL cos theta. Here take out this 2L plus 1 divided by 2I kr into PL cos theta as a common term. 2L plus 1 divided by 2I kr into PL cos theta, common term. Here the rest of the term is e power 2I delta L, here minus 1. Now, f of theta is equal to 2L plus 1 divided by 2Ik into e power 2I delta L minus 1 into PL cos theta. Without r, we have written. Then this is modified as e power 2I delta L minus 1 is modified as e power I delta L into e power I delta L minus e power minus I delta L. Now make your multiplication. E power I delta L into e power I delta L is e power 2I delta L. E power I delta L into e power minus I delta L is e power 0. Anything over 0, 1. We can get this term. Entire is multiplied by PL cos theta. Actually, e power I delta L minus e power minus I delta L divided by 2I is sin delta L. So instead of this, we can write 2I sin delta L. E power I delta L minus e power minus I delta L divided by 2I equal to sin delta L. E power I delta L minus e power minus I delta L is equal to 2I into sin delta L. Say instead of these two terms, we can write 2I sin delta L. This PL cos theta is present already. This 2I get cancelled. Therefore, f of theta equal to summation over L equal to 0 to infinity 2L plus 1 divided by k. This 2I cancelled out. E power I delta L sin delta L into PL cos theta. This is the value of scattering amplitude. Now the differential scattering cross section is equal to absolute square of f of theta. Sigma theta equal to absolute square of f theta. This is 1 by k square. Summation over L equal to 0 to infinity 2L plus 1 e power I delta L sin delta L PL cos theta, entire should be squared. The meaning of e power I delta L absolute square is equal to e power I delta L into e power minus I delta L. complex conjugate, that is equal to 1. See, this is the value of differential scattering cross section. Then the total scattering cross section is given by the formula 2 pi into sigma of theta sin theta d theta, limit varying from 0 to pi. See, write down the 2 pi as such. Instead of sigma theta, you have to substitute this value. Take this k square, 2 pi by k square. Then 2l plus 1 square, it is also a constant. Take note, sin delta L square is sin square delta L. Inside the integral, you have to write 0 to pi, the absolute square of PL cos theta into sin theta d theta. This is 2 pi by k square, 12 plus 1 whole square, sin square delta L. This is the standard integral. The value of this integral is 2 divided by 12 plus 1. Now, this 2l plus 1, this square cancelled out, 2 into 2, 4. Therefore, sigma total is equal to 4 pi by k square, summation over L equal to 0 to infinity, 2l plus 1 sin square delta L. This is the formula for total scattering cross section. For SOS scattering, the value of orbital angular momentum number L is equal to 0. Therefore, the differential scattering cross section and the total scattering cross sections are, see here, in the case of differential scattering cross section, this is the formula, sigma theta. If you put L equal to 0, you can get 1 by k square sin square del 0. Therefore, sin square del 0 by k square is sigma 0 of theta. In the total scattering cross section, if you put L equal to 0, you can get 4 pi by k square sin square del 0. Say this is a geometrical cross section, this is a total scattering cross section. The total scattering cross section is 4 pi times the geometrical scattering cross section. Anyway, it is noted that both the cross sections do not depend on the scattering angle theta, whereas these cross sections are depending on the phase shift delta. That's all about the low energy scattering.